So our project is all about this RGB LED mixer. As you can see that RGB stands for red, green and blue, and therefore this LED is capable of giving different colors by the combination of using different values of red, green and blue. Therefore this is what our product is all about. And coming to the introduction, as you can see that LEDs are becoming most used and they are used in different applications, and RGB LEDs are highly effective in most of the cases, and hence they are used throughout. And as you can see that RGB LEDs are a three LED package that can be intended to function like a display pixel and produce so many colors, like we can generate 16 million possible colors by just using these three RGB LEDs. And the components which we used in this project are a capacitor, resistors and 3 op amps, diode and 3 potentiometers. And this is the software implementation of the circuitry. As you can see that a sinusoidal signal is given to all the three inverting terminals of the op amp, while the DC supply is given to the positive terminals of the op amp or the non-inverting terminals. Here you can see that this op amp acts like a comparator. Therefore, if the positive value is greater than the negative voltage, then we get plus 15 volts as the output. And if the positive voltage is lesser than the negative voltage, we get an output of minus 15 volts. Therefore, one of the signal which is given to the inverting terminal or the negative terminal is the sinusoidal signal, while the positive terminal, we are giving a DC supply to the positive terminal of the op amp. As you can see, initially there are three different DC supplies connected to three different op amps. Let us consider the first case where voltage given to this positive terminal is 0, and the other signal is a sinusoidal signal, and it is a clamped version of it. Therefore, it doesn't contain any negative part. As you can see that voltage which is 0 is compared with the negative terminal of the op amp, and the output would be negative because the sinusoidal signal is greater than the positive supply which we are giving, and therefore the output would be minus 15, and therefore this would not make the LED glow. But if we are increasing this voltage to plus 2 volts or plus 3 volts, we get a certain duty cycle, say around 20% duty cycle, which is around 15 volts, while the negative 80% is minus 15 volts. Therefore, the intensity of the light would be changed accordingly. Therefore, we give different DC supplies to three different op amps. Therefore, we are generating three PWM signals. So initially, this is the sinusoidal signal which we are using, but we have a symmetry in this because the positive and negative parts are there, and therefore we had to clamp the signal in order to utilize the maximum PWM signal. So this is the clamped version of the sinusoidal signal which is given to the inverting terminal of the op amp. And as you can see that here there is no negative axis for this, a negative Y axis, as the signal is clamped. And these are the different PWM waveforms which we got from three different outputs of the op amp. As you can see, the first bit is around 20%, duty cycle is 20%, this may be around 50 and 90% of the duty cycle. So these are the three different outputs which we will be giving to three terminals of the RGB LED. And in order to make it clear, let me just show you a video to demonstrate this. As you can see that rather than using a DC supply, we use the potentiometer. Therefore, we are giving different voltage levels to the non-inverting terminals. Therefore, the intensity of the light varies according to the potentiometer reading. As you can see, the second potentiometer is connected to second op amp and we get different width, and the third is connected to the blue light. Therefore, we are getting different types of LED light based on this. And if we are giving a width of one thing and giving a second pulse width, we are getting a different light. Therefore, we are able to generate different colors by just changing the potentiometer reading. And you can see this brightness.